Adjunct Professor Moran, Macroeconomics 111. We've been discussing the aggregate expense model, and so far we've completed the private closed version of the aggregate expense model. Private because we assumed away government, and closed because we assumed away exports and imports. We did that because Keynes is all about the leakages. In other words, classical economics says that for every dollar you spend, someone catches that as income. So the act of generating output earns income sufficient to buy the output. However, Keynes points out that when money leaks out of the expense stream, either through savings, because you don't consume every dollar you make, or through taxes, or through imports, exports, then that dollar of income won't be available to buy the dollar of output produced. So to get a very simple overview of the entire model, we eliminated government and imports and exports, so the only leakage was savings, which was plugged by business spending at equilibrium being equal to savings. But now we're introducing two more leakages. We're going to introduce taxes when we introduce government, and we're going to introduce imports, which is a leakage, when we introduce X sub n. So that's the summary of the change we're making to get the complete model. Now, we're going to introduce something called the multiplier. And so if we have an equilibrium that is not at full employment, how can the government encourage the economy to either produce more output to fight a recession or produce less output to fight inflation? If we're short by $1 trillion, does the government have to spend the entire trillion? And the answer is no. All the government has to do is get the ball rolling by spending a little bit, and then some of that will be spent and saved, and some of that will be spent and saved. In other words, the initial spending on the part of the government will be multiplied, and there will be a larger change in output as a result. So the multiplier is found by the change in GDP, the initial change in GDP, divided by the change in spending. The formula for the multiplier is 1 divided by the marginal propensity to save. Since the marginal propensity to save is equal to 1 minus the marginal propensity to consume, you can use either of these formulas. The multiplier is the inverse of the marginal propensity to save. Savings is a leakage from the expense stream, so the more likely you are to save an extra dollar of income, the less of a bang we get out of the multiplier. The larger the marginal propensity to save, the smaller the multiplier. The smaller the marginal propensity to save, the larger the multiplier. In real life, the multiplier is about 2, but for reasons of fractions and arithmetic, our multipliers will be larger because of the marginal propensity to consume and marginal propensity to save numbers we select. Not only is there a spending multiplier, there's a tax multiplier. So the government can regulate the economy by encouraging more production or less production by changing its spending. They can also regulate the economy by changing taxes. And so if they leave you with more money by taxing you less, that initial change in spending resulting from a tax cut will lead to a larger change in output because dollars will be partly spent and partly saved. So let's take an example. Let's calculate the multipliers. We'll start by introducing the difference between gross domestic product and disposable income, which in the last unit was assumed to be equal. But you can see here that GDP is 550 and disposable income is only 530. The difference there would be taxes. So we're going to see that taxes here, 550 minus 530, taxes are 20. We're going to assume something called a lump sum tax. A lump sum tax. The tax will be the same at every level of income, which is something of an unrealistic assumption. It's a simplifying assumption so we can see the relationships better. So since taxes are 20, this will be 490. So gross domestic product is 490, but because there are taxes of 20, because we reintroduced the government, disposable income is 470. GDP of 550 minus taxes of 20 gives a disposable income of 530. There are only two things you can do with your disposable income: consume it or save it. If people are consuming 450 of the disposable income of 470, then they're saving 20 at this level of income. But when income rises to 530, people are consuming 495. So then people are saving 35. These little divots are meant to be delta signs, which in mathematics means change. So The marginal propensity to consume is found by the change in consumption divided by the change in disposable income. Whenever you do a marginal, whether it's in macroeconomics or microeconomics, the numbers have to come from two separate lines. It's a change measure. Originally, when we discussed the aggregate expense model, we compared averages to marginals. All the information comes off of one line for an average, two lines, because it's a snapshot in time. But a marginal is a change in time or statistics, and so the information has to come from two different lines. In this example, when income changes by 60, 530 minus 470, consumption is changing by 45, 495 minus 450. That gives you a marginal propensity to consume of 0.75. In other words, every time you get an extra dollar, you'll spend 75 cents of that. The marginal propensity to save can be found two ways. You can do the change in savings divided by the change in disposable income. So when income changes by 60, savings will be changing by 15. So 15 divided by 60 equals 0.25. The marginal propensity to consume plus the marginal propensity to save has to equal 1. So another way of finding the marginal propensity to save is take 1 minus the marginal propensity to consume. That's why you can use either to calculate the spending multiplier, 1 divided by the marginal propensity to save, or 1 divided by 1 minus the marginal propensity to consume. The multiplier is found with that formula. So we'll take 1 over 0.25, and we discover that the multiplier is 4. The tax multiplier has a different formula. You take the marginal propensity to consume of 0.75 and divide it by the marginal propensity to save of 0.25, and you get a -3. The marginal propensity to save is always a negative. That's because a tax reduction, a negative, has a positive impact on GDP. So if you give a tax cut, if you reduce taxes, you'll see that what we need to do is flip the sign. Now, how does this work? We've calculated the numbers. What do we do with them now? So we're going to take our aggregate expense line, and we're going to have two of them. We're going to call one full employment, and we're going to call one actual. So, as we mentioned in the last part of the partial aggregate expense model, there are inflationary and recessionary gaps. There are three different equilibriums. There's an inflationary equilibrium, a recessionary equilibrium, or a full employment equilibrium. So let's say this is GDP actual, this is aggregate expense actual, this will be GDP full employment, and this will be the amount of aggregate expenditures that results at full employment. This is aggregate expenditures. Again, think of that as buying. This is gross domestic product. Think of this as making, output, for example, and income. So we have all three measures of GDP on the graph. Let's assume from our problem that GDP in a recession is 490. And let's assume that GDP at full employment is 550. Now, any number off the 45-degree reference line is the same. Does the government have to spend the entire 60 to get us to full employment? This is the change in GDP we desire to take us from an unemployment level of output to a full employment level of output. If businesses make more, then they'll have to hire more workers and income will go up. And then we'll be buying an amount of output that's sufficient to generate full employment, which is not happening at this level of output. The formula we're going to use is the change in GDP equals the change in aggregate expenditures times the spending multiplier. We know we want GDP to change from 490 to 550, that we want it to increase by 60. We don't know how much government spending. It can be any component of aggregate expenditures, CIG, GXN, But often the government takes responsibility for solving recessions, so it'll be a change in government spending times the multiplier, which we solve for here. Now, we're going to divide each side of the equation by 4. That cancels this 4 and gives us 60 divided by 4, which is 15. So, aggregate expenditures, in this case government spending, has to change by 15. If at this level of output the government spends 15 more, that will take us to a disequilibrium of 505. Buying, because we're on this side of the 45 reference line, buying will be larger than making. There will be an unplanned inventory decrease, which sounds bad, but it's very good for business. They thought they were going to sell 100, for example, and they sold 120, so their inventories fell by 20. So, if that's true, business will respond by making more, and you'll go up this aggregate expense line. You won't go up at a 45-degree reference line because the marginal propensity to consume is less than 1, 0.75. For every extra dollar of income someone makes, they'll only spend 75 cents. The slope of this line is the marginal propensity to consume. Businesses will continue to make more as long as people continue to buy more. And this will continue until buying is equal to making at this new equilibrium, which will be generating sufficient income to produce full employment. So what we did here is we introduced a new concept of the multiplier. We discovered how to calculate the multiplier using the marginal propensity to consume and marginal propensity to save. Now, we can also do this with a tax change. The formula for a tax multiplier is change in gross domestic product equals the change in taxes times a tax multiplier. We see that the tax multiplier is 1 less than the spending multiplier in negative. Okay, so we're going to have a negative tax multiplier of 3. We want GDP to change by 60. Do you have to give a tax increase or a tax decrease? Well, you have to give a tax decrease. But whatever this number is, it'll have to be a negative because you need a negative times a negative to result in a positive change of GDP. So arithmetically, the tax multiplier has to be the opposite direction of which way you want to go. You want GDP to go. So when we divide both sides of the equation by 3, you need a tax reduction of 20 in order to cause a change in GDP of 60. Notice that the change in taxes, in order to cause a change in GDP of 60, is larger than change in spending required to cause a change in GDP of 60. That's because a change in taxes will be partly saved and will leak from the spending stream. Whereas when the government spends 15, 100% of that 15 counts as a change in GDP, which we'll discuss in more detail soon. Alright, so we're adding back government spending, which means we have taxes. And we're going to assume that government spending is equal to taxes, so the leak is plugged. There's an injection of 20 and a reduction. There's a spending of 20 and taxes of 20, for example. We're going to add imports and exports, and we're going to assume trade is balanced. Imports is a leakage, exports is an injection. So there'll be no leakage if the trade is balanced. Okay, so we discussed a little bit the difference between equilibrium, full employment, and our actual equilibrium. In this example, this would be a recessionary gap because full employment, because actual GDP is below full employment. If it were reversed, and this is aggregate expenditures actual, and this is aggregate expenditures full employment, then we're trying to buy more output than we can produce at full employment. So if the natural rate of unemployment is 4% and unemployment falls to 2% because we're producing more output, that could be inflationary. And so this would be considered an inflationary gap. So this is our introduction to the complete Keynesian model, which incorporates government and imports and exports.